So, we're going to go ahead and do these problems. Now, the issues that I have seen kids have throughout the day is reading, okay? When you have word problems, you have to be very careful with how you read it. Because if you read it too fast or you read it to not understand, you are going to mess up. Okay? So you need to be careful with how you read it and understand what you're reading. Okay? And I'm already going to tell you right now, people have been messing up with this part of the problem and with this part of the problem. Okay? Because you are not truly reading to understand what it is saying. Okay? So reading is very, very important. It's not just about math skills. It's can I read and interpret it appropriately. All right? So I have a deck of cards that has a total of 52. Right? In this deck, what am I given? Or what are they telling me that I know I have? I have 4 kings. Just like in a deck of cards, I have 4 kings. I also have 4 what? What are the cards do I have 4 of? 4 kings, 4 and jacks, and then aces, and all the numbers, right? There's 4 of each, right? So I have a total of 4 kings, okay, in this deck of cards, okay? I'm shuffling my cards. I'm going to do probability, and how many cards must I pick? 2. The key word here is pick. This is the action in the sentence. Juan Negrete, I see you're not paying attention. The action is telling me that I must do what? Pick. So my action tells me that I am picking 2 cards. Now, ideally, I want to pick those 2 cards and get a what? A king. Okay? This is telling me that I want to pick 2 kings. Now, whether I pick the 2 kings or not, that's a separate story. But I want to pick 2 kings. Okay? But I have a total of 4. Right? Now, the important part here is that I'm replacing. That is why we said is independent. Okay? What this means is that you have 52 cards. When I pick one, do I throw it away or do I put it back? I put it back. And so because I'm putting it back, is the total of my deck ever going to change? No. You will always continue to have 52 cards no matter what because you are replacing. Right? So I'm going to go ahead and find the probability of picking a what? King, queen, ace, 1, 2, 3. What am I picking? King. So I want the probability of picking a king. Haley, pick your head up. I want the probability of picking a king. Okay? How many times am I picking a card? What's the action? How many times am I doing the action? Twice. So because I am doing the action twice, I am going to have 2 fractions. I'm going to represent a fraction for every single time I do something. If I'm going to have to do this 2 times, then I'm going to show 2 fractions because I'm going to do this twice. If it tells me to do it 5 times, then I will do 5 fractions. If it tells me to do it 10 times, then I will do 10 fractions. Okay? Now, I am starting in the very beginning. Okay? Think of this as an experiment. Okay? I have 52 cards. Okay? How many cards am I starting with in the very beginning? 52. Okay? I pick a card. Okay? I pick the card. Do I put it back or do I toss it to the side? I put it back. So if I put it back, did the number of cards in my deck change? So then the second time around when I pick a card, how many cards do I have? 52. So nothing has changed at all. Okay? Now, I am focusing on kings. In this deck of 52, how many of them are kings?
4.
So I have the option of choosing out of how many kings? 4. Because that's how many are available. There are 4 kings that are available to me. Now, let's say I pick a king. I'm putting it back, right? So do the number of kings in my deck change? Mm-mm. It is still 4. So a rule of thumb here, guys, is that the denominator stays the same, your numerator stays the same. If the denominator changes, then you also have to change your numerator. Okay? So if the numbers change in the bottom, then they change at the top. If they stay the same, then they stay the same. Okay? Because if you're taking away on the bottom, you're taking away on the top. If you are not taking anything away, then it stays the same. Okay? So this is what we have. Does anybody have any questions or need a clarification? No? Okay, so now what's 4 times 4?
16.
And now what's 52 times 52? 2,704. Am I happy with that fraction? Why not? Simplify it. So go ahead and get your calculators and simplify it and tell me what my answer is. Was it? 1/169. Does anybody need me to show you how to do that? Okay. So what we're going to do is we're going to get our fraction of 16 divided by 2,704. Okay. And now what I have to do here is I'm going to press math. Okay, so the math button. And then I'm going to, math button. And then I'm going to press fraction because I still want to see it as a fraction. And I want to see if it can simplify it. So I press frac. Then once I'm here, I will press the enter button. Enter. And what fraction does it give me? 1/169. And that's how you get that fraction. Okay, so that's how you simplify. Now, is our fractions going to be simplifiable all the time? No. If it's not simplifiable, it'll literally just give you the same answer again. If you can't simplify it, it'll give you a new fraction. Okay? But that's what we do here. Any questions? Nope. Okay, so now let's go ahead and look at number 2. This one's different because now we're not independent. Now we are what? Dependent, because we're not putting things back. Okay, so I have 52 cards. How many of them are kings?
4.
Okay, in this deck we are shuffling them and I want the probability of picking 3 kings. So what does picking 3 kings mean? I'm taking no. What? Huh? Try to explain it a different way.
You can't replace
I cannot replace. And how many times am I doing these things?
3 times.
So I'm doing it a total of 3 times. I am picking 3 times. So I'm doing this action of picking a card from a deck 3 times. Okay? So then how many fractions am I going to have for the probability of a king in this problem?
3.
3. Why do you say 3, Haley?
Because you're picking 3 times.
Because I'm picking 3 times, right? So because I'm going to pick 3 times, I have 3 fractions, right? So having 4 kings and picking 3 kings is not the same thing. Having 4 kings is what I have. Picking 3 kings is what I'm going to do, okay? The action versus what you have, what you're given, okay? So I have my original deck of 52 cards, okay? So when I'm starting this off, how many cards do I have initially?
52.
52. Okay, putting it back. No, I'm not replacing it. So now I have 51 cards. You see how my totals are now changing? Because I started with 52, doesn't mean I have 52 because I'm not putting it back. So now I have 51. So now I take another card away, and how many do I have left?
50.
50. In my third try, I will have 50 cards left. Okay? So notice, when we have a dependent event, my denominators are changing. Because every single time that I take a card away and don't put it back, I am changing the probability of the chances of picking what I want. So when it's dependent, your denominators change. So if my denominators are changing, do you think that's going to affect my numerators? Yeah. Because in the beginning, how many kings do I have?
4.
4. Right? Guys? Right? I took a card away. Do I still have 4 kings available? No. How many do I have?
3.
Okay, I took another card away. How many kings are available now? 2. Okay, and so notice, if my denominators change, my numerators change as well. Okay, because I am changing the probability of picking that card again. Okay, so what's 4 times 3? 12 times 2? Okay, now use your calculators. 52 times 51 times 50.
132,600.
132,600. That's a 3. Yeah, 132,600. So you should go ahead and simplify this or see if there's a simplified version. 25, right? And there we go.
Number what?
5,525.
You multiply
What does this little dot mean? If I wanted addition, what would I put there? Yeah, this is not multiplication. This is what, guys? Good question, Negrete. Any questions? Okay, so now I'm going to give you guys 6 minutes on the clock. Okay? Everybody good? Ready to move on? All right. 6 minutes on the clock. I want you guys to do 1, 2, 5, and 6.